Welcome to the K3 pebblestone demo video on K3 pebblestone manufacturing. Manufacturing in the fashion industry is a challenging process. This is largely caused by the fact that fashion items come in different colors and sizes, leading to many so-called variants. K3 pebblestone offers manufacturing functionality that enables these many variants to be handled in all aspects of the production process in an easy and efficient way. In this video, we are using the jacket Bruce with item number 20,000 as the product to show you how this works. Jacket Bruce is available in 10 different sizes, from XXS to 5XL. Jacket Bruce is available in 5 colors: black, grey, blue, red and green. Scrolling down to fast tab replenishment on the item card, we see that routing in-house and production bill of materials BOM 0001 have been set up for Jacket Bruce. The routing is the description of the actual production process, holding as many different steps as needed. In the example, we have kept it very simple by just defining a 4-step routing. In this routing, we have defined cutting, stitching, finishing, and packing as the so-called work centers. In practice, the routing will be more detailed. The cutting work center could, for example, consist of 3 different cutting tables, each defined as a machine center. The stitching work center could consist of several production lines, each again defined as a machine center, or even more detailed, with each sewing machine as an individual machine center performing a very detailed task like stitching a sleeve or attaching the sleeves to the body. The production bill of materials, usually just called BOM, holds the list of fabrics and other materials that are needed to produce the Jacket Bruce. For the best possible planning and availability of the necessary materials, a BOM per variant of the end product is needed. However, an average seasonal collection easily holds up to 250 items. If each of those is available in 4 colors and 10 sizes, this means we would need 10,000 BOMs for one season only. 10,000 BOMs could in theory be created manually one by one, but in practice this is undoable. K3 pebblestone enables you to just define one base BOM per item, put in place some smart settings and rules, and let the system create the many thousands of BOMs on variant level for you. We now see the base BOM for the Jacket Bruce. In the header of the BOM, we see that size L has been defined as the default size and color blue as the default color. In the lines part of the BOM, we see that we need 6 components to create the Jacket Bruce. Fabric with code F-110, lining with code M-116, yarn with code M-10000, metal buttons, a front zipper, a size label. We also see how much or how many we need of each of the components. The column inherit color defines what we call the one-on-one relations for colors. The check mark on the line of the fabric tells the system that it should use the same color of the fabric as the color of the end product. So red fabric for the red jacket, blue fabric for the blue jacket, etc. Naturally, you would think, but a system needs to be told. In the example, we have also set up color inheritance on the lining and the yarn. The column inherit size defines the one-on-one relations for sizes. The best example for this is the size labels. Of course, we need to put a size label XS in the end product size XS, a size label S in the end product size S, etc. Again, sounds natural, but a system needs to be told. For products with a second size dimension, for example jeans that come in colors, waist sizes, and in seam sizes, we could also use the inheritance function on the second size. By using a growth percentage or value, we can let the system automatically define a higher consumption of, for example, fabric on larger sizes. In the example, we have defined 2.6 meters of fabric for the default size L. The growth of 5% will make sure that the next size, which is XL, is set up to use 5% more than that, and the size after that, again, 5% more. Size S will use 5% less, and size XS, again, 5% less. On the yarn, we have set up a growth value instead. The defined consumption of yarn on default size L is 6 meters. For size XL, the system will automatically add 0.5 meters, and on size XXL, again. Now, let's have a look at the result of all of this. The system shows this in an easy to understand matrix format. In the header of the matrix, we see that we first look at the quantity per size. We recognize the value of 2.6 meters for the fabric on size L, and see the growth when we move to the larger sizes and the lower values when we move to the smaller sizes. In the same way, we recognize the growth value of 0.5 meters on the yarn. When we change the settings in the header, we can see how the colors of the components are linked to the colors of the end product. We see that the system has chosen the same color of fabric, lining, and yarn as the colors of the end product. We see that the buttons are available in completely different colors, which have been linked to the colors of the end product. Steel color buttons for the black and grey jacket, white buttons for the blue jacket, and black buttons for the red and green jacket. We see a similar setup for the front zippers. Finally, we see that the size labels are always white, regardless of the color of the end product. When we change the settings in the header again, we can see how the sizes of the components are linked to the sizes of the end product. Fabric, lining, and yarn do not have sizes. These materials come off a roll and can be cut in any required length. For the buttons, we see that one size of the button is used for multiple sizes of the end product. 20mm buttons for end products in size XXS, XS, and S, 22mm buttons for M products in size M, L, and XL, 24mm buttons for M products in sizes XXL, 3XL, 4XL, and 5XL. We see the same idea for the front zippers, which are obviously available in lengths varying from 40 to 60 centimeters. Finally, we see that for the size labels, a one-on-one relation has been set up, with the same size of the label as for the end product. Everything we just saw in the matrix has been automatically filled by the system, based on the base BOM that we defined for Jacket Bruce and the smart settings and rules that we have applied. If, for any reason, we want to deviate from the structural rules that we have applied for one or more variants, we can just change the appropriate value in the matrix. For example, when we normally always use steel color buttons on black jackets, but only for this one we want to change that to white color buttons, we can just change that in the matrix, and the system will register this in the BOMs for all sizes in black. In the background, the system has actually registered 50 different BOMs, because we have the Jacket Bruce in 5 colors and in 10 sizes, resulting in 50 variants, so one BOM per variant. The next step in the process is to create demand. This could either be through a forecast or through actual sales orders. In this sales order for customer Brittany's Fashion, we have entered a large quantity of 690 pieces for the Jacket Bruce. In practice, we would have many smaller pre-sales orders that add up to the total quantity which we need to produce. In the matrix, we see how the 690 pieces are divided over the different colors and sizes, with the same quantity and division over the sizes for each color. Try to roughly remember these quantities, because we will see them again in a minute in the next steps of the process. With the item defined, the routing and BOM defined and attached, and the demand created, we can now ask the system to tell us what to do. What should we produce, and which materials do we need for that? For this purpose, we use the planning worksheet. When you first open this, it will be empty. By choosing Prepare and then Calculate Regenerative Plan, you can make the selections you need. Which forecast, which sales orders, which time frame, which items, and then click OK. The system will then fill the worksheet as you see here. What does the worksheet tell us? First, it indicates the quantities we need of the different materials. For example, 1,820 meters of fabric. When we drill down on that number, we see how that is divided over the different colors. Or 690 size labels, one for every jacket, nicely divided over the sizes. And 1,380 buttons in different colors and diameters. The column order type tells us that we should create purchase orders for these quantities. If we would have available inventory or outstanding purchase orders already on any of these materials, the suggested quantity to purchase would be lowered accordingly. The vendor number is inherited from the default vendor that is defined on the specific material. Then we see that the system suggests to create a production order for 690 pieces. Looking at the details through the matrix, we recognize exactly the quantities that we saw in the sales order earlier. Any of the suggested quantities can be manually changed here, if needed, for whatever reason, before we carry out the suggestions. This is done by choosing Process, Carry Out Action message. After making the right selections and clicking OK in the pop-up screen, the system will actually create the suggested purchase orders and production order. Let's have a look at one of the purchase orders that results from all this. 3 of the 6 materials obviously come from the same vendor, called London Fashion Makers. We see lines for the size labels, lining, and metal buttons with exactly the quantities that we saw earlier in the planning worksheet. Then let's have a look at the production order that should have been created. It was created as a firm plan production order, but we have in the meantime changed the status into released, which enables us to show how we can post consumption of materials and output of finished end products on the production order. On the release production order, we see one line for the jacket Bruce with the quantity of 690 that we know so well by now. Opening up the matrix shows us the details per color and size that we also recognize. Choosing line and then components shows us that the system registers the materials we need for every individual variant of the end product, resulting in an almost endless list. All components are repeated as many times as there are variants for the jacket Bruce, so 50 times. Don't worry, we'll show you in a second how you can continue on an accumulated level easily and efficiently. Choosing line and then routing directly shows us the production steps on an accumulated level, not repeated per variant of the end product. That's a matter of setup. If you want to be able to separate the production process per color or size, you can also set up the system in such a way that it shows the steps 50 times. Choosing line and then production journal gets us where we can, as promised, enter consumption and output. We see the materials with the planned consumption quantity based on the BOMs per variant. Clicking on the quantity for the fabric shows us the matrix with the division over the colors. We can change the quantities here when the actual consumption differs from what we plan through the BOMs. The more expensive materials are set up to be handled manually in this way. Clicking on the quantity for the buttons shows us the matrix with the division over the colors and sizes. These could be changed here manually as well. However, we could have chosen to let the system post a consumption of cheaper materials automatically at the release of the production order called forward flushing, or at the finishing of the production order, called backward flushing. For materials for which we let the system automatically post a consumption, we need to carry out a regular inventory check to establish what differences have occurred in the actual consumption of these materials compared to what was defined in the BOMs. Finally, we can enter the output per production step in the production journal. The output quantity is set equal to the order quantity by default, but can be changed here, either to a lower number, for example when you have not been able to cut enough fabric for the required number of end products from the available fabric quantity, or to a higher number when the cutting was so efficient that you could produce more end products than required. Of course, the output needs to be defined on variant level, for which we can open the well-known matrix again. After entering all consumptions and output correctly, the production journal can be posted and the production order can be finished. That's it for this episode. Thank you for watching. If you enjoyed it, please don't forget to subscribe to our YouTube channel. Thanks again, and see you next time.